In this tutorial, we will be discussing polyprotic acids. Polyprotic acids are acids that have more than one hydronium ion, proton or H+, that dissociates in water. Each H+ that dissociates has its own Ka and own pKa value. The first Ka is much greater than the second. The Ka result from a H+ dissociation from a neutral compound, and then the Ka2 is the H+ ion is leaving an anion, negatively charged species. So there's the difference right there. Is the first one is leaving a neutral compound, while the second one is leaving a negatively charged compound. This requires more energy to remove, thus getting the Ka much smaller. So here's some examples of some polyprotic. There's H2, H3PO4, H2SO4. Notice that they have multiple hydrogens that can be donated. Bases that can accept more than one hydrogen will also have multiple Kbs and therefore multiple pKbs. This is an illustration of the dissociation of polyprotic acids. So the first one, that hydrogen here, there's H2C6H6O6. Only one of those hydrogens are going to be given off. And so therefore you have the dissociation of that one single hydrogen. And then we take this over here, and notice it's negative now. That next hydrogen is going to be removed to form its own H3O+. Notice that the second one is much smaller than the first one. The first one is times 10 to the negative 3, while the second one is times 10 to the negative 12. You would add them together to find the total ionization. Notice that the second one is so much smaller that it's practically negligible. So here's some more examples. H2CO3, when it removes the first hydrogen, has a Ka of 4.3 times 10 to the negative 7. When it goes and tries to remove that second hydrogen, it drops, I should say, to 5.6 times 10 to the negative 11. Phosphoric acid, which has 3 hydrogens, once it removes the first one, its first Ka is 7.5 times 10 to the negative 3. Take this one over, and now it's being removed from a negative compound. It drops to times 10 to the negative 8. And then finally, to remove that last hydrogen, it drops to times 10 to the negative 13. And that's an overview of the trend for polyprotic acids.